Hello, my name is Darren Thomas. I'm the Director of Educational Research Techniques. In this video, we're going to take a look at inverse trigonometric functions and try to see if we can understand and explain what they do and their purpose. So let's go ahead and begin. Now, what I'm going to do here is I'm going to try to give you the punchline, or in other words, the purpose of what they do, what trigonometric functions do, and then I'll try to go back and explain how they're going to achieve our goals. So imagine we have a triangle. And of course, this is not drawn to scale, obviously. We have a right angle here, obviously. And then we have theta. We don't know the angle yet. And let's just say, I don't know, let's say it's like a 7, 12, 15 triangle or something. Now, here's the thing. Normally, when we're dealing with the trigonometric functions, we know the angle and we want to figure out the length of the sides. We've done that before. But with inverse trigonometric functions, what we're trying to do is we have the length of the sides, and we want to know what angle do I need to have these different lengths of these sides. Now, before I go any further, it's important that we understand two words here, and that is inverse and reciprocal. Now, when we're talking about inverse, we're talking about opposite. And when we're talking about reciprocal, we're talking about, again, these are colloquial terms. We're talking about like equal or something that's similar to repay in the same kind. So, for example, if you smile at somebody, they will often reciprocate by smiling back. So you give a smile, you get a smile. That's what reciprocity means, to get what you gave, basically. However, an inverse is this. When you smile at somebody, they frown at you. They give you the opposite reaction. And so when we're dealing with inverse trigonometric functions, we're dealing with something that does the opposite of the regular trigonometric functions. In other words, what they're doing basically that if whatever sine does, the inverse of sine does the opposite of it. It removes the influence of the sine, if you will, to put it in layman's terms, as to make it as simple as possible. And that is essentially what is happening here when we're dealing with these, we call them inverse trigonometric functions. Now, you guys know about the different properties, or the how the sine function works. So, if I have sine of x, okay, the inverse is not 1 over sine x. This is the reciprocal. This is incorrect. This is incorrect. What is really happening is I have sine of x, and the inverse of that would be sine to the negative 1x. And we're going to talk about how this works in a few moments. But this is kind of the big picture of what is happening here in this particular experience with the inverse trigonometric functions. Now, let me see if I can show you a few graphs here. So I'm going to go over here to my graphs. All right, so this black line right here is the sine function. And you can see that it's a periodic function. In other words, it repeats itself several times. Now, what's happening is that when you graph and we call it the arc sine, the arc tangent, the arc cosine, etc. You can see here that the domain of the arc sine is limited. That is because we need it to be a one-to-one function. In other words, for every output, there must be one input. Now, with regular periodic functions like sine, cosine, and tangent, there are many potential inputs for the output. And so it's not one-to-one, and that can cause problems in terms of dealing with this. So when we're trying to graph these things, we want to make sure that they're one-to-one. And so what's happening here is that the computer naturally limits the domain of the arc sine from -1 to +1. I hope you can see that. I can zoom in for you a little bit if that's kind of hard to see. You can see right there, this is 1, this is -1. It limits it automatically for the sake of having one input for each output. Whereas for the regular function, for the regular sine function, it can be many inputs for the output. And so that's what's happening there. But this is how it looks. And you can see that it's kind of almost like a mirror image reflection of what's happening with the actual sine function. So when this is kind of going up, this is kind of not going up, not quite as steeply. And then it loops up here while this starts to go down. That's what's happening. So that's the sine function. Now I'll show you the cosine function. This is the cosine function. Hopefully this looks familiar. Now this is the arc cosine, this purple line here. Let me go up a little bit. This is the arc cosine. You can see it goes up much higher here. So we still have the same domain where we're going from -1 to +1, but you can see here that it tops out a little bit higher. Its range is a little bit more extended. And so when we zoom in right here at the key part here, this purple, you can see that this kind of has a little loop here, and then this is kind of behaving in another manner. Again, because of the action of the function here, the behavior of the function. And of course, my personal favorite, this is of course tangent. I gotta zoom out for this one to appreciate this one. And then here we go, we got arctangent here, right here. So you can see with the arctangent, the domain is whatever you want basically, as far as you want. Whereas the range, again, we're going from about -pi to -pi/2 to pi/2, if you will. Now here's the thing, with the arctangent, you can see that it's flipped on its side almost at 90 degrees. You can see that with the behavior of this one. Whereas with the regular tangent, it goes up like this in that periodic manner that we've talked about before. So these are the behaviors of these different inverse trigonometric functions and what they do. So let's go ahead and go back to the slide here. Okay, now one more thing I want to explain to you before we conclude this video is the relationship between sine and arcsine, cosine and arccosine, tangent and arctangent, etc. So let me see if I can just show you by giving you a pattern first and keeping this as simple as possible. All right, so sine of y equals x. That means then that sine to the -1 of x will equal y. What does that mean? Let me give you an example. Let's say I have sine of 1/2. That's going to equal, let me put the wavy line. That's going to equal about 0.47. This means that if I do sine to the -1 here, and I put 0.47, it should equal about, put the wavy lines again, about 1/2. And so let me go ahead and show you this as an example real quick. Bring my calculator down here. So sine of 1/2. So we get 0.479. Now, if I change this and I do arcsine of 0.479, you can see here that I get about 1/2. So you can see the inverse here, the inverse that's happening here, and how you're getting these different values here. And that's what's happening every single time. Okay, let me go to the next slide. So the same idea applies for cosine and also for, of course, tangent. So if I have cosine of 1/2, this is going to equal about 0.87. Then if I do that, I can say cosine, inverse of cosine, that's going to be 0.87. That's going to equal about 1/2. You can calculate this on your own time if you want. And then again, we could do tangent also if we really wanted to, as necessary. Now, what's going to happen is that another thing we have to talk about is how things are converted to degrees. But we're going to say that for the next actual video when we do these things. So remember that our end goal is to take this knowledge of inverse trigonometric functions to find the angle that is appropriate for whatever size the triangle are. That's what you really have to keep in mind here. So let me see if I can kind of conclude these things and wrap up the video. So we've been talking about inverse trigonometric functions. And essentially what you use those for, as I've already said several times, is you take the inverse trigonometric function, sine, cosine, tangent, to find what angle you need given the size you have for your triangle. That's what you use it for. And so again, we talked about the difference between inverse and reciprocal. Inverse means opposite. If I smile, the inverse is to receive a frown. However, the reciprocal is to get a smile back as well. And so this is important to understand as well. Now after that, we looked at the different graphing of the different functions of sine and cosine, etc., etc. And what's happening here is that with the sine and the cosine function, you limit the domain from 1 to -1. Because you have to have that one-to-one function here. If you don't limit it, you get lots and lots of values. lots of potential values, and it's not really a function in terms because it doesn't pass what they call it, I believe it's the horizontal test, and so you have to limit the domain for these different functions. And the range is often from negative pi over 2 to pi over 2. That's normally what the range is as well, in case you were wondering. Back to the videos here. And so the last thing I left you with is that when you have the sine of y equals x, the inverse of that is sine to the negative 1 with x in here equals y. And so basically what's happening is that the inverse trigonometric function is undoing the behavior of the regular trigonometric function. Now, in the next video, I gotta really emphasize this. In the next video, when we get to that in a few days or whatever, we're going to learn how to apply this theoretical stuff that we've talked about today that probably confused a lot of people. And remember, the end goal for us as we talk about inverse trigonometric function is to figure out this angle here when I know the sides of the different, I know several of the sides of a triangle. Remember, if all this theoretical stuff doesn't make sense, this is the application part for our purposes. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.